Chapter 12.2, Surface Area of Prisms and Cylinders. All right, so the definition of a prism, it is a polyhedron with two congruent faces called bases that lie in parallel planes. Let's take a look. All right, so if you recall for a prism, the prism is named for its bases, so this is a hexagonal prism. If you look at the base right here and count the sides, 1, 2, 3, 4, 5, 6. All right. This has 6 sides, so it's a hexagon. It's called a hexagonal prism. For a prism, the bases are parallel and congruent. So you notice on the top and on the bottom, there are both hexagons. They are both parallel and congruent on the top and bottom. All right, so a few definitions. The lateral faces, they are parallelograms and they connect the bases. So you can see right here in blue, these are the lateral faces. All right, it's basically going to be all of the faces, not including the bases. All right, so those are the lateral faces, and the lateral edges are just the segments that connect the bases. So these right here are the lateral edges. All right, so for surface area for a polyhedron, it is the sum of the areas of its faces, and the lateral area for the polyhedron is the sum of the areas of its lateral faces. All right, so in other words, if you just did the area of the lateral faces, the part in blue, that would be the lateral area. If you included the part in blue and the two bases, that would be the entire surface area. Example 1, find the surface area of a rectangular prism with height 2, length 5, and width 6. Okay, they are all in centimeters. Now, in their example, they used a net. They basically took a rectangular prism and unfolded it and did all that to find the surface area. You don't need to do that for a rectangular prism. So here is our diagram, okay? Why is this called a rectangular prism? Well, that is because the bases are both rectangles. You can see right here in the front and right here in the back. All right, those bases are both rectangles. They are both parallel and congruent. So that's why it's called a rectangular prism. All right, so we're going to find the surface area. We basically just add the area of all the faces. All right, we have faces on the front and back. We have faces on the left and right. And we have faces on the top and bottom. Okay, top and bottom. Okay, those are all going to be rectangles. So the area, we're going to add up all the areas. The area for a rectangle, we know that to be length times width. All right, so let's do that. For the front or back, same thing. We see this up-down height is 2, so I can fill in a 2 right here. And the front is right here. It's just going to be 5 times 2. All right, 5 times 2, that's 10. All right, we're just doing length times width. For the left-right, let's look at the one on the right. Right here, it's going to be 2 times 6. Okay, for the one on the right, that's 2 times 6. And that's just 12. And finally, for the top and bottom. All right, let's look at the bottom right here. We have a 5 times a 6. All right, right here on the bottom, 5 times 6. Again, we're just doing length times width. 5 times 6, and that's a 30. Notice we used each length 2 times. We used the 2 twice, we used the 6 twice, and we used the 5 twice. All right, so you want to get the sum. 30 plus 10 is 40, plus 12 is 52. Now, is that the surface area? No, because each face has a twin. All right, for each one, we only did the front or the back, the left or the right. All right, so each face has a twin. So for the surface area, we're going to have to multiply this by 2. All right, that's going to be 52 times 2, which is 104. The units were in centimeters, but for area, that's going to be centimeters squared. All right, and this 2 here, that's because each face has a twin. All right, so we needed to multiply the sum times 2. All right, so here, the height of a prism is the perpendicular distance between its bases. In a right prism, each lateral edge is perpendicular to both bases. A prism with lateral edges that are not perpendicular to the bases is an oblique prism. All right, so right here we have a right prism. In this case, it's rectangular. But the definition of any right prism is that the lateral edges are perpendicular to the bases. All right, it's basically straight up and down. So you see all these right angles here. This edge is perpendicular to the edge of the base. And same thing on the bottom. Okay, it's basically straight up and down. Now, if you go to the oblique prism, it's basically leaning to the side. The bases are still parallel, but these lateral faces are not perpendicular to the bases. Okay, so the height is basically measured like this, right here. And if you were to extend this line on the base, it would be perpendicular right here. All right, because remember, the height has to be perpendicular to the bases. It's the perpendicular distance between the two bases. So that's the definition. That's the difference between oblique and right. The oblique one, the lateral edges do not make a right angle with the base. Okay, so the height is measured outside of the prism. On the right prism, the height is one of the sides. Okay, this would be the height. This would be the height right here. All right, but on the oblique prism, this right here, this length right here, that is not the height. That's not the height right there. Okay, the height has to be straight up and down, perpendicular. All right, so the surface area S of a right prism, S equals 2b plus pH. So in this case, capital B is the area of one of the bases, capital P is the perimeter of one of the bases, and H is the height of the prism. So we learned in the past, for the area of a regular polygon, we have the 2 right here, and the area of a regular polygon we learned is 1/2 apothem times perimeter. So that B, that area of the base, can be broken up into this formula right here. And we still have the plus pH. Now if you do 2 times 1/2, 2 divided by 2 will just cancel. And you're left with AP plus pH. So this formula works as well. It's really the same thing, just written in a different form. So you can use that, or you can use that right there. Okay, and in this formula, the lowercase a, that stands for apothem. All right, so this is what it would look like on a diagram. The height H is the height of the prism, So we can say that is the distance between bases. All right, the height is the distance between the bases. Capital B is the area of either one of these bases. And of course, the perimeter is the distance around one of the bases. All right, this perimeter is for the base. This capital B is the area for the base. Example 2, find the surface area of a right pentagonal prism. Let's take a look. All right, so we learned the surface area for a right prism. It's going to be 2b plus ph. All right, so let's see. H is the height of the prism. We can see right here, this is the height connecting the two pentagons on the top and the bottom. So 9 is going to be your height, H. Now, for the perimeter, we see all of these sides are marked congruent, and each side is 7.05 feet. All right, so let's see the perimeter. I'm trying to get all these letters so I can plug in for the formula. The perimeter is each side, which is 7.05. And there are 5 sides. Let's see, 7 times 5 is 35. And 5 times 0.05 is 0.25. All right, so that's going to be used for the perimeter. And now the base, the area of the base, that's a little bit of a pain in the neck. Okay, I'm going to redraw the triangle, but we see that each side is 7.05. So this right here on the triangle is also going to be 7.05. We see the radius drawn in. This is the center, and this goes to a vertex. This is the radius. It's 6 feet. So that means this radius is also going to be 6 feet. All right. So I am going to redraw this triangle so I can find the apothem right here. See, this is the center right here. So if we find the height of the triangle, that's going to be your apothem. All right, so drawing the triangle, the two sides are both 6s, okay? Those are both radiuses. So this is a 6, and I'll draw in the other radius here. That's also going to be a 6, and the bottom of the triangle is going to be 7.05. Now we have an isosceles triangle here, 6 and 6. All right, let's draw in the height of this triangle, which is really the apothem. All right, instead of labeling it height, I'm going to label it A for apothem. All right, because if you look at the diagram, this is the center of this polygon. So if we can just draw in the apothem here and find that perpendicular distance, we have the apothem A, and we're in business. So remember, we have an isosceles triangle. When you draw in a height and make it perpendicular to the base, it's going to bisect the base, okay? Because this is two congruent triangles. This is hypotenuse, leg. And on this side, hypotenuse, leg. We have two congruent triangles. The base is bisected. Let's find half. Let's find half of 7.05. And I'll do that on the calculator. And I get 3.525. So each half of this base is 3.525. 3.525. All right, because the base was bisected by this. And now we can use Pythagorean theorem. I know it looks bad, but it's just some decimals. That's all. We'll let the calculator do the work. A squared plus B squared equals C squared. All right, we have two right triangles here on either side. The hypotenuse is always going to be C, all right, across from the right angle. So if C is 6, that means C squared is 6 squared. A and B, it doesn't matter which is which. Since we already called this A for apothem, I'll leave that as A. And this side length right here, I'm going to use that for B. Okay, so A is just A. I'll leave that alone. A squared. A squared stays as is. And for the B squared, that's going to be 3.525 squared. All right, looks worse than it really is. Solving for A squared, the opposite of plus 3.525 squared is minus 3.525 squared. I'm going to do that to both sides. Minus 3.525 squared. And plus minus, that cancels. We're left with the A squared equals this. How do we undo the squared? We take the square root. Square root of A squared is going to be the square root of this right here. Okay, square root of A squared is just A. And square root of this mess is a repeating decimal. So what I am going to do, I am going to leave the square root alone because I don't want to round off yet. I'm going to leave the square root alone and just do this part right here. 6 squared minus that. I get 32.475. All right, and that is simply because I don't want to round off just yet. All right, so that's going to be my apothem, and now we're almost all set. Now, remember we said before, instead of 2b plus pH, we can use AP plus pH. So since we found the apothem, instead of 2b plus pH, I'm going to use AP plus pH. All right, so if you plug in 1/2 apothem times perimeter in place of B, and then multiply it by 2, you'll just get AP right there. All right, so we said the apothem, A, radical 32.475. All right, the perimeter, we found at the beginning 35.525. 35.25. All right, so that's your apothem, and that's your perimeter, and then perimeter again, 35.25 times the height h, which we said was 9 feet from the diagram. All right, and that's it. We're going to do let the calculator do the work right here. Rounding off, I get 518.13. The units were all in feet. So when you do an area, that's going to be feet squared. Final answer. Pain in the neck, but that's the answer. All right, so the perimeter and the height were easy to find. The pain in the neck part was finding the apothem. That was the real pain in the neck, to find that apothem. But once we did that, we just used the formula. All right, one more example. We want to find the surface area. This is a triangular prism. Notice the triangle in the front and the back. Those are the bases. All right, so surface area. We said it a minute ago. That's going to be 2b plus pH. Now, in this case, I am not going to break this part up into apothem times perimeter. Why is that? Because I cannot find the apothem here. Okay, if I drew in the center of the triangle and drew in the apothem, it would be very difficult, if not impossible, to find. So really, we might as well just find the area of this triangle right here, and that will be my base, capital B. All right, so let's draw, once again, let's draw this triangle. All right, and we have an isosceles triangle here. All right, the two sides are 5 centimeters each. So I'm just going to draw an isosceles triangle. All right, these sides are 5 each, and the base or bottom is 6. We want to find the area of this triangle and plug it in for B. All right, so this one is not as bad as the last one. We have an triangle, isosceles, if you draw in the height. Okay, and like I said, in this case, this is not the apothem because we're drawing in this right here. So this is the height of the triangle. And it makes a right angle on the bottom. If the base is 6, half of 6 is going to be 3 and 3. So this is 3, and this is 3. All right, so using Pythagorean theorem, or do we even need it? All right, if you go across from the right angle, that's 5. This is 3. What's the most common right triangle? The most common right triangle is a 3, 4, 5, okay, where 5 is the hypotenuse. And we can see that 5 is the hypotenuse, so if this is 3, this right here is 4. If you don't believe me, you can use a squared plus b squared equals c squared, but you're going to get 4 right here. So this is the height of the triangle, H. All right, so capital B is the area of the base. So that capital B is the area of the triangle. Okay, and what's the area of a triangle? That's 1/2 base times height. So that's going to be 1/2. This is the base right here on the bottom. That 6 is your capital B. I mean lowercase b. And the height we just found is right here. It's perpendicular to the base. The height is 4. All right, half of 24 is 12. So we got that out of the way. All right, so 2 times the base is going to be 2 times 12. And perimeter, that's pretty easy. All right, perimeter is the distance around one of the bases. All right, I'm making a mess here. But the perimeter is going to be 5 plus 6 plus 5. I'll just plug that in for P. 5 plus 5 plus 6. Okay, in place of P, the perimeter. 5 plus 5 plus 6. Finally, this H is the height of the prism, not the height of the triangle. It's the height of the prism. It's the distance between the two bases from one triangle to the other. So that is your height, and that is 12. All right, and this is all calculator work. Unless you want to do it in your head, 2 times 12 is 24. This is 6 plus. This is 16 times 12. All right, I'm going to go to the calculator. I get 216. All of my units were in centimeters. So for an area, that is going to be centimeters squared. All right, and that is for a triangular prism. All right, and if you don't have a 3, 4, 5 triangle here, you can just use Pythagorean theorem to find the height, and that's it.